So vectors. All the vocabulary is up here. It's bolded. So if you are a highlighter kind of person, you can go highlight things. Vectors, they're used in physics because it has to do with force and velocity, which we've talked about in here already. Vectors have magnitude and direction. A vector tells you what direction something is going, and it tells you how long it is going for. Magnitude is length. It says it somewhere in here. Magnitude is the length. Right here, magnitude is the length. And then direction, that's like pointing which way it's going. So vectors, they look kind of like a ray that you learned about in geometry. It has an initial point and has a terminal point. It tells you which direction it is going, and then the magnitude is how long it is. You will see symbols for vectors. For example, this symbol right here is PQ, and it has kind of like a half arrow thing above it. That means vector, PQ. You also will see vectors written with just one bold lowercase letter, like vector V, or you might see vector V written that way. But you'll see it in the notes as we're taking it. Okay, so here's an example where we have two vectors. And in this problem it says, show that these two vectors are equal. So vectors are direction and magnitude, which is length. So we need to show that the direction is the same and that the length is the same. Can you see they're both pointing the same direction? You see that? Okay. In math, we can find the direction by using slope. Remember slope? Rise over run. Or y2 minus y1 over x2 minus x1. What would be the slope of each of these lines? 3 over 2. Is that correct?
No.
Try again. Up 2 over 3. For each of them, they have the same slope. So for these vectors, they have the same slope. That means they have the same direction. Because they're both going positive. They're both going up 2 over 3. That's the same direction. So we have to also show that they have the same magnitude.
Isn't it 3 over 2 because it's rise over run?
We're going up 2. Yes, but we are going up 2. Up 2.
Oh, okay. I thought we were going from like 1 to 4.
We are, but up is 2 though.
Which 2?
This here is the ordered pair 1, 2. The y value is the up. You were looking at the 1, not the 2. Gotcha. All right. Magnitude is the length. And to find length, when we are on the ordered, what's it called? XY axis on the Cartesian plane, to find length, we use the distance formula. Do you remember distance formula? Distance formula? Do you remember doing that ever?
Square root of
Square root of
y2 minus y1
well,
squared.
I'm not going to have space to write it. There it is. It's going to be, actually I'm going to start with x, but it doesn't really matter if I start with x or y, but I'm going to start with x. x2 minus x1 squared plus y2 minus y1. It doesn't really matter if you start with x or y because you're going to add them together and it doesn't matter the order in which you add. But we're going to keep using x first today, so I'm just going to write it first. That is the distance formula from Algebra 1, from geometry, from Algebra 2. That's the distance formula. That is the Pythagorean theorem. That is the Pythagorean theorem. You're just finding the change in the x's and the change of the y's, and you're finding what c squared is, and so we're doing that. Pythagorean theorem. So for this one, the very first vector is rs. To find the magnitude of RS, I just wrote find the magnitude of RS, of vector RS. I just wrote that using symbols. That's what those two double lines mean. It means find the magnitude of vector RS. But that just means use the distance formula. So we're going to subtract the x's and square that answer, subtract the y's and square that answer. So it will be 4 minus 1 squared plus 4 minus 2 squared. Which is the square root of 9 plus 4, which is the square root of 13. It's vector RS. We also have to find the magnitude of vector PQ. You're going to do the exact same thing and use the distance formula. This one's a little bit easier because of 3 minus 0 and 2 minus 0. And once you find out that they're both exactly square root of 13 long, then you know that they have the same magnitude. So these are equal vectors. Okay, so what do these double lines mean? The magnitude, which means the length, which means distance formula. Right. So something else about vectors that, again, is vocabulary is we can write vectors in what's called component form. Component form is where you have a, and it's written right here in this little space. The V1 is a horizontal change, and V2 is a vertical change. So we write the component form in chevrons. The first number is a horizontal change, the second number is a vertical change from the initial point to the terminal point. Kind of slope related, only it's written in a different format. Now, they have a formula for component form of a vector. I do not like the fact that they use P's and Q's in the book. So I'm going to write over it. We're going to scribble it out and change the letters so it makes more sense to us. The component form of the vector with an initial point P, I'm not going to call that P1, P2. I'm going to call that X1, Y1. So the initial point is just going to be the first X and the first Y. Then the terminal point Q, we're going to call that X2, Y2. They're just changing what they're calling it. We can change, we can call it whatever we want as long as we do use it correctly in the math. So their formula for component form, since they use P's and Q's, I'm changing that. I'll write it over here where I have space. The formula is x2 minus x1, comma, y2 minus y1. It's just a change in the x's and a change in y's, written in that form with chevrons. What did you say? The little, whatever. That's the name for that symbol. That means this is component form. It is not an ordered pair. It will look like an ordered pair unless they have the chevron. Then it looks like component form. Magnitude, we've already learned how to find magnitude, but if you know the component form already, which is V1 comma V2, if you know the component form, you can just do V1 squared plus V2 squared and then square root that. And I'll show you that shortcut. So if you already know the component form, this would be the magnitude or the length or the distance formula, if you already know the component form. Here's some more vocabulary. If the magnitude of the vector equals 1, it's called a unit vector. That's if the magnitude is 1. See, I told you a lot of vocabulary, but I promise this stuff's not hard. It's just so much vocabulary and different symbols that you don't use all the time. Okay, so here's finding the component form of a vector. So we're going to use that formula that we just wrote down to find the component form and the magnitude of the vector. So it tells us our initial point and our terminal point. So the component form of vector v is subtract the x's, -1 minus 4, comma, subtract the y's, 5 minus -7. So the component form is -512. The magnitude. Make sure you're using the symbols in your notes so that you can learn what these symbols mean. The magnitude, that's the distance. I'm going to use the shortcut formula that says just take these numbers, square them, add them, square root the answer. How did I get that so fast? How to get that 5 squared plus 12 squared, square root is 13.
Did you just do -5 plus 12 because of the square root?
No, I did not.
Spell out your 13.
It's a triple. Yeah, it's a 5, 12, 13 triple. So
Okay.
this is Pythagorean theorem. That's what we're doing. If it's a triple, it should go a little faster. They're not always triples. It might be a square root or something. Okay, so that's finding component form and finding the magnitude from the component form. Definition of vector addition and scalar multiplication. If we're trying to add two vectors together, all you do is you add their x parts and you add their y parts. So when we're in component form and we've got vector u and vector v, you just add the two x's and add the two y's. That's how you add them. It's really basic. To do scalar, you just take whatever the scale is, whatever the number you're multiplying by, and just multiply each number. Multiply the x and multiply the y by that number. You just kind of distribute it in. So here's 3 examples. A says do 2v. I forgot to sign your next page. A says do 2v, so we're just going to take 2 times vector v. So the answer to question A is -410. Questions? Basic. You just have to know what to do. That's all. Part B says take vector W and subtract vector V. I'm going to write it over here because of space. I feel like I can't fit it all in, but you probably have room. I'm writing bigger up here. I'm going to take vector W and I'm going to subtract vector V. So I'm going to take 3, 4, the component form, and I'm going to subtract vector V, which is -2, 5. And to subtract these, we just subtract the 2 x's and subtract the 2 y's. So I'm going to have 3 minus -2 and 4 minus 5. And I get 5 -1. Questions about that one? If I were going to draw this, and you might not be able to fit it right in that space, you might have to do the drawing over here. I did mine like up here when I did it on my paper. If you were going to draw this, I'm going to show you how you would draw it. Because I believe it's a sketch some in your homework. Our first vector is vector W, and vector W is 3, 4. So we go 3 for the x, and we go 4 for the y. So there's vector W. You go 3 on the x, you go 4 on the y. Vector W. Kind of like the hypotenuse of a right triangle. Then from that, we're going to subtract vector V. So we're going to subtract, this is what we were doing, we were going to subtract negative 2, and subtract 5. So since this is the x's, horizontally, I'm going to subtract negative 2, but that's too complicated. What am I going to do instead? I didn't subtract negative 2. What did I do? Actually added 2. So horizontally, I'm going to add 2. And then vertically, I'm going to take away 5. So from this point, I'm going to a new point. That is horizontally adding 2, vertically subtracting 5. And what point am I sitting at now? Do you know what point we're sitting at now? We're sitting at the point 5 on the x, down 1 on the y, negative 1 on the y. And that's the component form that we found when we used this addition and subtraction. Okay, but that's visually what we're doing with vectors. Remember, I am recording this, so if you did need to go back and look at what we did, it will be there for you. Yeah.
So this is all new, that you're gonna apply this to say like super triangles that you're running.
There will be something that overlaps. You'll see in your homework, there's a question about log cosines, using all this stuff. So there will be some overlap, but you won't even need to worry about that until after you've taken your test. I just want to make sure you have the notes so that when you're done with your test, you can start on the assignment and see where your questions are. Okay. You just cannot wait to get done with trig though, right? Okay. The class is pre-calculus and trig. Sorry, you have to take it though. All right, question C is vector v plus 2 vector w. So we're going to take vector v, which is negative 2, 5, and we're going to add on 6, 8. Where did I get 6, 8 from?
2 times.
I took that scalar and I just distributed it to w. And so my answer would be vector in component form for 13. All right. This is all the properties of addition and scalar multiplication. You can look at it if you need it. These are just all the properties that you could use. Okay, the next example, for example 4, we have how you can find a unit vector. To find a unit vector, you take the vector in component form and you divide by the magnitude of the vector. Take the vector in component form and you divide by the magnitude of the vector. Or you could take the vector and multiply by 1 over the magnitude. Either same thing. So here they told us the vector in component form is negative 2, 5. And we have to find the unit vector and then verify that that has a magnitude of 1. So 2 things. How do you find the unit vector? We take the vector in component form and divide by the magnitude. So what do I need to find? The magnitude. How do I find the magnitude when it is in component form? Square root negative 2 squared plus 5 squared. So we got our magnitude. Then we have to take the original component form and divide it by the magnitude. So our new component form would be negative 2 over radical 29. Comma 5 over radical 29. I don't think the book did. And And then the last thing is they say verify that that has a magnitude of 1. Verify. So we're going to use the magnitude formula on this. So we will do negative 2 over square root 29 squared plus 5 over square root 29 squared. So I get the square root of 4 over 29 plus 25 over 29. Which is the square root of 29 over 29. Which is 1. So we had to verify that the magnitude was 1. Is anything terribly hard? No. Is it get confusing with language? Yes. Especially if you're math. Okay. Taking one before we got started. I paused it. Do you want a snack?
Yes. Wait, you didn't pause it.
No. It. Yeah, but it says paused. Right? Oh, dang, it's not saying paused. Okay, we are on standard unit vectors. This is like really, really basic. It makes it look super complicated. It's not. We've got standard unit vectors where, if looking at the picture, vector I and vector J are just one unit out from 0, 0 in just horizontal or in vertical direction. So one of them is 1, 0 and the other is 0, 1. So one unit away. Just straight. And then from there, we can make a linear combination of vectors from a different vector. If you're looking up right here, if you have a vector in component form, you can write that as being multiplied by the I vector and the J vector, the unit vector I and the unit vector J. It does not affect the number at all because you're multiplying by 1. But we can use this to manipulate, more complicated questions. It does not affect any values. So when we have something like this, and it says, let U be the vector with initial point 2, -5, terminal point at -1, 3, write U as a linear combination of the standard unit vectors I and J. We just need to find the component form of U. So we're going to do -1 minus 2 and 3 minus -5. So you're going to do the component form, which is -3, 8. And it asks you to write that as a linear combination. So you're going to take the, why am I saying, okay, I did something wrong. Or maybe I did it wrong. I might have done it wrong on my paper. You're just going to write the horizontal with the I, and I just made it say imaginary, it's not imaginary. We're at the horizontal with the I plus the vertical with the J, and that's all it's asking you to do. Because I is the vector that is 1, 0, so it doesn't affect the numbers at all. J is the vector 0, 1, it doesn't affect the numbers at all. They're just asking you to rewrite it like this. Yeah.
So, there has been like a verifying
Oh,
That's
this,
weird.
like cursive versus bold. I can't really type it. It looks different when they're typed. It actually is in your notes. It talks about how you make the I value, or the I. It says, note that the lowercase I is written boldface to distinguish it from the imaginary I. I'll talk about that. I just ignored that. Okay, so then we can do vector operations using these linear combination vectors. They've given you u and they've given you v, and we have to find 2u minus 3v. So we're going to do 2 times this one, so that'll be negative 6i plus 16j minus 3 times v, so 6i minus 3j. See, I write the imaginary all the time for Algebra 2. I don't write vectors all the time, so I'm not used to writing them, but you know, if they just use a different letter. So then I can't just add these. I can only add like terms. So I'd be adding negative 6 and negative 6. So we get negative 12i. And I'd add 16 and 3, so I get plus 19j. So it's just using regular addition that we've always used in biggest vectors. Okay. Any questions about that one? I just want to check that other question. For some reason, I thought I had it wrong on my paper, but. Okay. All right, this is the last thing, and this is where it really comes to play what we've been doing. So you'll notice that u is a unit vector, and there's a picture. It is in a different spot on my notes than it is in your notes because it couldn't fit it up here. It would be too small. They have gone through to show you that if the component form is xy, it can also be written as cosine theta, sine theta. Because of all the things that we've been doing right now, remember x is the same thing as cosine. X is the same thing as cosine. X is the same thing as cosine theta. Y is the same thing as sine theta. Remember all the stuff that we've been doing. You can also rewrite that as cosine I plus sine J. You can also, I don't know, but I'm trying to explain all of this to you so you're not like completely confused when you try to work, because it's not hard at all. You just have to understand what this is. You guys understand x is equal to cosine theta. Is x equal to cosine? Y is equal to sine. So it can be rewritten in component form. It can also be rewritten using the linear combination, the way that we wrote it. The angle theta is called the direction angle of the vector. And then it goes through here and shows you how we can use this to solve for things, but what you really want to see is that V is the magnitude in those double lines. That's the magnitude. And theta is the angle. And then it keeps going on to show you how we can make this equivalent to tangent also. I'll show you how we would use that in a question, but it goes through. You're going to have to look at this when you answer some questions in your homework. There's also a picture showing you where x, y, and the theta all are. So find the direction angle of each vector. So I give you 3i plus 3j. You want to look at this and you want to compare it back to where they have I and j, right here. So if we have 3i plus 3j, then I know that cosine is 3 and sine is 3. So I'm going to draw a picture where cosine is 3 and sine is 3. That is otherwise known as the component 3, 3. And Our goal is to find the angle, theta. So according to that angle, what two sides do we know? We know opposite and adjacent, that's tangent. So the tangent of that theta is 3/3. Well, the tangent of that theta is 1. What's theta? 45 degrees. Should know that from the unit circle. So the next one, same way, it's telling us that the component form is 3, -4. So if I drew that, I would go 1, 2, 3, 1, 2, 3, 4. 3, -4. And there's my vector. I don't know what guys trying to line up with. 3, -4. So if we try to find theta, theta is going to be this. That's what theta is. When I'm not going to find that, I'm going to find the reference angle, theta. I'm going to find that angle. And then I will find the pink one next. So according to that theta, what two sides do we know? We know the opposite, and we know the adjacent. So we know tangent is equal to -4/3. Is that one that we have memorized? No. So how do we find the angle if we don't have it memorized? What do? You do inverse tangent of -4 divided by 3. You do inverse tangent. That will give you approximately -53.13, because that's the theta here, but I want the other theta. So how do I find the other side? 360 minus, plus that number. Since we're using our calculator, let's do 360 plus the answer that we just got. And that will give us the pink theta. I better write it in purple so you can actually read it though. 306.87. Okay. So you have notes, you will have a video to refer to, you will have the notes that I will upload to Canvas to refer to. You won't have to think about this again until after you've taken your test. So the rest of class today, which is 15 minutes, to still work on your review for the test and ask the question. You also have 2 XH spells before we take our test. And yes, I know you have other classes and other tests, so plan accordingly.